What's up, bosses? I'm JoeMan543. We're doing math tonight. Yeah, not the most exciting thing, but I need to do math homework, and the streams help me stay regular on that, because for some reason I don't like doing math homework. I don't know why. Anyway, yes, welcome to the stream tonight. Hopefully the microphone sounds good. I can never tell with the meter here. I get an idea, but I never tell for sure. Anyway, I need a drink of water real bad. And I'd like to welcome everyone that's here right at the beginning of the stream. Welcome, Noobified and Commander Cody. Just you two for now. And that's okay, it's a math stream. I'm not expecting anything. The fact that anyone shows up is a surprise, because it's math. Not terribly exciting. Fridays, I do my exciting streams, though. Well, more exciting at least. That Blue Badger, welcome to stream. Can't wait to figure out how many watermelons Joe can buy with 13x and 5y bolivares. Bolivares, I think that's a currency. Yeah. How many watermelons can I buy with that? Hey Joe, can you help me generate ideas for making art and content? All I have is my Lovecraftian void mind and voice what I do. Sure. And Evil Plays, welcome. Last Psychic Vampire Elder. Yeah, ideas for art. I guess it kind of depends, because you can just choose objects from the world, right? Cars, Master Chief, a couch. There's all sorts of things from the world, but maybe you're thinking more subjective, like a situation, maybe? Ooh, I got it. Action hero running, jumping over the hood of their car, and like they're gonna then like touch the ground, then hop in their car and go, but like while they're hopping over the hood. That'd be pretty cool. Yeah. All right. Well, it is time to do math. So, and I will say, kind of not feeling it tonight, so we might not do full 2 hours of math. So, turn the music down just a hair. Yeah. I also do magic. Can't sing, can't draw, so I let my soul do that. Hey, I wouldn't say I sing or draw very well either. But trying is what's important. So, okay, well, let's get into it. So last time, did a 4-hour stream. That was brutal. Yeah. Last time was a 4-hour stream, which was quite brutal. And this time, definitely no more than 2 hours. It might even be 1 hour. I don't know. Let's see. So here's our progress. So real numbers is nearly entirely filled out, which is awesome. As well as equations and inequalities, plus geometry. Yep, geometry is important. You know, most of these are pretty filled out. We are lacking in radical expressions, rational expressions, and functions and graphs. So we're probably gonna get some stuff in that area, you know, get well-rounded here. I will say now, we'll do another stream like this next week, and let's look at the calendar here. So here's today, the 10th, and so next week is the 17th. My school starts on the 29th. Now, I don't want to take the test like the night before, because, you know, I need to sign up for the classes. Ideally, I would have done this back in spring, but here we are. Anyway, I think I'll stream again next week doing math, and then off stream, I will take the test. I wish I could stream that, but yeah, I don't think I'd get away with that one, streaming me taking a real test. Anyway, yeah, so stream next week and take the test, I don't know, maybe over the weekend or something. And then the following week is like the last Wednesday before school, and then school starts. Probably won't have much homework by here. And I'm gonna have to check with the professors, because like I like the idea of doing homework on streams, but I can kind of see how they might not like that. Let's say I'm doing that week's math, and I'm giving off all the answers on stream. You know, I can see how professors wouldn't like that so much. So anyway, yeah. All right, chat. Let's see. Venezuelan Bolivar, 1 to about $500,000 US. Oh, that is quite the conversion rate. Wow. Oh, $1 US. Okay, $1 is about 500,000 bolivars. Okay. Yeah. OMG, this is calculus. Ah, it's pre-calculus. See up here, prep for pre-calculus. Oh yeah. Okay. Yeah, let's actually get into the math here. So I'm going to continue my path, and I will have to set up the camera again, so you can see my notebook. So let's see. Solve for W. All right. So this is gonna be super easy. I am gonna set up the notebook. You're not gonna see my face for a bit. You're gonna see my hands, see my notebook. So I just gotta set this up real quick. I still don't have a great solution for all this, but you know, we try. Okay. What I'm doing is I'm kind of shoving the base of the camera into a handle of my water bottle, and it's not quite going in here. Okay, I guess that'll do. So there's my notebook, which is upside down. So we're going to do that, and then I'm gonna drag this over a little bit. We don't need the sides there so much. Okay. Yeah, so that's what we're gonna do. Kinda, let's see, we don't need the top so much there. Gain some bottom. Expand this out. And boom, there's a notebook. Okay, so you can see my hands. See my pen. My TI-30. I have a TI-84 too, but we're not quite to that point in math. Yeah. Joe, you are beyond my level of intelligence. Puts on dunce cone hat. Oh, there's definitely different categories of intelligence. You can have someone that's like really, really smart in math, and like they're a total idiot when it comes to life lessons. Like, I don't know, don't give money to obvious drug dealers. Okay. Yeah, so probably won't even need the paper here, but yeah, solve for W. Basically, this is absolute values. So remember PEMDAS, how you do like your certain order of stuff, and the P in PEMDAS is parentheses. You know, you do everything in your parentheses, and then you work on the outside stuff. So this is kind of like that, except everything in here is positive. So let's say it was 4 minus 8. That would give you a -4, but then you absolute value it, so it just becomes positive, and so then it's 4. So yeah. Absolute value, it's not that it makes it positive exactly, it just it says how far it is away from 0, which happens to also make it positive. Anyway, so let's see what the explanation is down here. So yeah, distance from 0 on the number line. So positive, absolute value of A equals B. So if B is greater than or equal to 0, A equals B, or A equals -B. Yeah, it could be either option. Faran, Abbas, welcome to the stream. The guy's that good with math and bad with a lot of other things is here. Sup? Good to have you. Your equation for velocity or for inertia last time was very helpful, if I'm remembering right. I hope I'm remembering right. Force equals mass times acceleration. Anyway, I'm getting distracted. Oh yeah, so importantly here, if B is greater than or equals 0, then A equals B, or A equals -B. You know, because this B right here could be either one, right? So it's just its distance away from 0. And then if B is less than 0, then absolute value of A is B, has no solution. Okay, so hold on, so why is that? Okay, so if B is greater than 0, oh, I get it, because this A has to be positive. So if B is less than 0, like if B is -2, A can't possibly equal -2. Excuse me. Oh, Tangerine Puma 28, welcome to the stream. Been a while since I've watched you. My nose just stopped bleeding. I'm sorry your nose is bleeding. Besides that, I want to know what GPU and CPU you have. Did you upgrade to Windows 10 yet? I've noticed you use 7. Yes, I used 7 for a long time. I did finally upgrade a few weeks ago. Yeah, so thought MSI made gaming equipment. Ah, yes. I got this from a laptop that I purchased several years ago. Got a gaming laptop for college because really gaming just means high-end and really powerful. All right, we're getting distracted. So let's start the module here. So, all right, so I'm skipping ahead here. So in this case, 4w minus 2 equals 6. So probably get w alone. Let's see, so plus 6 to both sides. Or in this case, set that negative 6, and then, plus 2 both sides. Okay, so it splits either way. It splits where the right side of the equals is positive or negative. That's how they go about this whole one or the other. So then w equals 2, w equals negative 1. And w can be negative 1, that's fine. We just can't have that. Okay. Gotta be positive, just like the equation. Okay, so I'm gonna write this one out. And my microphone's a little bit in my eyesight here. I know you can't see on camera, but all right. And I'm gonna write it out, and then I'm gonna make sure that this is actually focused. Okay. Make sure that my camera here is the best focus it can be. I think that's about there. Okay, yeah, so this splits two ways. We have 3v plus 6 equals 9, but then we also have 3v plus 6 equals negative 9. So that's how it goes with the absolute values. So then we just sort of solve it down from there. 3v minus 6 from this one. Let's see, so 9 minus 6 is going to be 3. V equals 1. And then over here, same thing, minus 6. It's going to go a different direction though. We're going to have negative 15, negative 9 minus 6, negative 15. V equals negative 5. Cool, so we get the two V options. So we have 1, and we have negative, not negative 58, we have negative 5. So I'm pretty sure that's right. Awesome. Uh-oh. This one's equal to 0. That's concerning. Let's see. Let's still draw it out here. Okay. So this would split into 2x minus 12 equals. Well, you can't really have a positive and a negative 0, right? So that just means 2x equals negative 12. X equals negative 6. Yeah. You know, if we go back to this equation, we can verify it by plugging these numbers in. So this 1, if we plug it in here, 3 times 1, so 3 plus 6 equals 9. That's valid. Negative 5, so that'd be negative 15, no. Negative 15 plus 6, which is negative 9, absolute value 9 equals 9. That's valid. All right, so that verifies. Come over here, x equals negative 6. Let's plug that in up here. So 2 times negative 6, that gives us negative 12 minus 12. If this was plus 12, it might work out, but it's not. If it was plus 12, okay, that still wouldn't work out actually. This is going to be no solution because 2 times negative 6, that's negative 12 minus 12, that's negative 24, and negative 24 or 24 does not equal 0. They equal 24. Or negative 24. So this is going to be no solution here, I think. My answer is incorrect. That's embarrassing. Okay. Oh, I'm silly. I think it's supposed to be 6. Let's see. So what did I not do here? So if we take a plus positive 12 there. See, this is why we do practice. Just hypothetically, you know. We took that. Oh, that's negative 16. Never mind. Negative 12. Wait, how did I... Oh my goodness, I just moved over the... Ah, I'm an idiot. X equals 6. Man, those negatives will get you. It's just one solution. X equals 6. I had this same problem last time, too. Last stream. I missed a sign. You don't just move it over, silly. You plus 12. Okay. Next. Yeah. I'm glad everyone here is so invested in math. Because, clearly, I am struggling. Okay. We do need the extra practice, so bring it on. That's such a simple, silly thing. You know? You gotta remember your signs. Okay. And this splits into that. We can save this. There we go. That's the worst 6 I've ever seen. This is a pen, though, so... Alright, negative and positive. So we plus 12, so we'll get 6 there. Plus 12, we get 18 there. So we get 1 and 3. I think that works out. Gotta say, I don't know. I'll be honest, IDK, I don't know why I'm so interested. Yeah. Okay, that's embarrassing. I'm being too rushed with this. Let's see. So that one works out. Is it because it equals negative 6? This should be no solution. This should be no solution. Oh, man. Yeah, because if you plug it back in, you can't do anything over here to get equal to negative 6. Man, I'm dumb sometimes. Yeah, there's nothing you can do to equal negative 6. It's impossible. What kind of math y'all doing? This is pre-calculus. And I'm being a little bit dumb. So, this is why we do practice. Yeah, no solution for that. Okay. Remember the rules for signs. Yeah. I need the practice, that's for sure. Okay, so new equation. It does equal a positive, so that's a good start. That literally just looks like 13. Here, let's make that a little more definitive. Okay. So then we split this out. Then we do the other one. Minus 12 off of that, get negative 9. Then minus 12 off that, negative 15. Double checking, yeah, minus 12 is correct on those. W equals negative 3, and W equals negative 5. It's equal positive. We can plug it back in to verify, so negative 3. Plug that back in, 3 times negative 3, that is negative 9. Negative 9 plus 12 does equal 3. And then we plug this one back in, negative 5, so negative 15 plus 12 is negative 3. Absolute value makes it positive 3. 3 equals 3. All right, that is valid. So let's pop this in here. So we have negative 3 and negative 5. All right. Hooray! You know, I thought that would be easy, and it most definitely was not. All right, well, let's keep going here. So, we're dealing with some square roots here. We're multiplying square roots. Okay. So how do we do this? So we simplify them. So in other words, like this 27, I know we can pull a 3 out of there at least. So we simplify So that really we can pull 16 and 6, which means we can pull a 4 out. And then this one we can pull a 3 out. So really we're going to have 12 square root 6 times 3 square root 3. Yeah, so it goes to that. Oh, just got an Amazon delivery to my front door. That's cool. Anyway, so then 12 times 3. Then do those, and then we get 9. Okay, so I am going to write this down. Square root 96. And so then that turns into 12 square root 6. 3 square root 3. Alright, so then those multiply together to 36. And those multiply together to 18. And then we can simplify that more. 108 square root of 2. Okay. So, seems straightforward enough. Yo, is this your first time doing this kind of stuff? I suck at square roots, so I will learn and suffer with you, my friend. Not my first time, but it's been... Oh, geez. So 2014 is when I graduated from high school, but I didn't actually do any math classes my senior year, so 2012 and 2013 is... It has literally been 10 years since I did pre-calculus. That is the last class I did in high school. So I'm just relearning what I learned back then. It's somewhere in my brain. I just got to recover it. All right, we'll get a line there. I'm going to move my microphone just like... There's no good place for it. I'm trying to look down. My microphone's in the way, so I can't see my notebook. Okay. So square root 24. Square root 98. All right, so let's break this one down here. We got 8 and 3. And that happens to be 2 and 4. And that 4 is 2 and 2. So we can pull 2 out, and those will turn into a 6. 98. Well, that's 49 and 2. And that pulls out... that pulls out 7s. So that's cool. So that turns into, let's see, 4 times 2 is 8 times 7 is 56. So 56. And then we multiply the insides. So 2 times 3, that becomes 6. 2. 6 times 2 is 12. And we can pull 4 and 3 out of there. Pull 2 and 2. So then those get to pop out. So 56 times 2 is 112. Square root of 3. I think I got that right. What you studying in school? Computer science is my major, if that's what you mean. There's a surprising amount of math in computer science, but like sometimes the math is weird. Like logic gates and that sort of stuff. Like technically it's math, but it's more like logic. They don't have a logic category of school. They have a math category. Okay, so 112 square root of 3. I hope I got this right. Hooray! All right, next problem. If I get 2 in a row right, then I if I get 2 in a row, then I get to skip the third problem. If I don't get it right, then I have to do the third math problem. So let's hope I get it right. All right, square root of 20 times 4 square root 80. Okay. I guess I'll start by breaking these out. Got some 2s out of that one. This one, we got 4 and 20. And I know we can... Why do we keep writing other numbers? I know we can pull 4 and a 5 out of there. So, this is going to be an awkward... Okay, yeah, that was very awkward to draw. Okay, and so then this is going to turn into 2 square root of 5 times, let's see, 4 times 4. That's going to be 16 square root of 5. Ooh, and then we're going to get a nice clean number out of this here. So yeah, 5, 5. So I could just skip a step, but I'm not going to. Okay, so 2 and 16, that makes 32. 5 and 5 makes 25. But, you know, 5 and 5, well, ta-da. So then we have 5 times 32. 160, I think. I am going to calculator that one. 5 times 32. Oh, yeah, it's 160. 160. Okie doke. That's a very nice number. Awesome. Cade Sass or Catases? I don't know. The second one sounds kind of cooler. I was a comp sci major. Cool. Ouchie, I was a mechanical engineer major, and 2 years in, I decided I hated doing calc. So now I'm in music production. Yeah, I mean, the way I see careers is you should pick something you're good at, right? But sometimes you kind of hate what you're good at. Or if it gets turned into a career, you're going to hate it. For example, I like making videos, but the few times I've done it professionally, I did not enjoy it as much. So that's why I don't pursue that career. I'm fairly good with computers, and it's a very broad field. So I've decided to go with that field because I don't dislike it as much when I go into the professional setting. In fact, I'd say the professional setting is more interesting than school, or more interesting than any of my own projects. Anyway, yeah, so when it comes to career, pick something that you can tolerate someone telling you to do rather than just doing your own ideas. Yeah. All right. Try not to be the dropout statistic. Come on, you got this, Solomon Kane. I believe in you. Wonder if you'll be doing any other streams on other subjects, Joe. Hey, it depends on what my professors allow me to do. I talked about that earlier. They might not like me doing homework live on stream because then I might be giving out answers. It depends. We'll see. Let's see. Solve the following system of equations. I've got 2 equations. So, yeah, we could pull x and y out of those, kind of, sort of. All right, we have 2 linear equations in 2 variables. So, one way to solve a system is to eliminate one of the variables. So, yeah, you could, like, solve it into, like, x equals y kind of deal. X equals y plus this. And then you plug that y into the x, so 5y blah 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 plus 3y. Then you just have y's up here, then you have y equals the thing, and then you plug it back in, then you get x equals the thing. That's one way to do that. I think that's what it's talking about here. Yeah, so... Yeah, so I think... Our problem, we eliminate the variable y. So 3y equals... I don't quite understand. Why are we multiplying everything by 3? Like, I get it at 3y. So we multiply everything by 3. That gives us 9y. What are they? Oh, that's the second equation. Oh, they're working with each other. Okay, so we get positive 9, negative 9, and then they'll cancel out. Okay. So they cancel out. Then we have the x's just left over. Okay, they're... Man, I was being kind of weird, kind of silly there. Okay, so the equations are working together. I guess that's why they call it a system of equations, huh? Because it's a system. Okay. So, Oh, wow. I didn't know computer science had the highest dropout rate of all majors. That's a little scary. I will say that I have completed all the computer classes of my associates for computer science. I just have to do a few math classes. So this fall, I'll be starting on the bachelor's computer science classes while working on the associates math classes. So I'll have the associates soon. I at the very least want to get that. But yeah, the bachelor's is the goal. So, okay, I'm getting distracted. So since it's a system of equations, I get it now. They're kind of working together. So we wanted the 9's to be kind of like opposite here, positive and negative. Then we can eliminate the y's, 13x, solve for x. All right, that's easy enough. And then now that we know x, we can pretty easily find y. We just sort of plug this -5 in and bada bing, bada boom, y equals that, x and y. So let's see. So we solve a system, or no, we have a system of two linear equations. We solve a system. I think what that is really meaning is where, like if we graphed this, where would they meet? So yeah. What math do you have to go up to? Calculus. Although technically calculus is a prerequisite for physics, and so I'd say physics is the highest math, even though it's physics. So okay, well, let's start this. So remember, system of equations, these are not separate things, they work together. So 2x minus 7y, make sure that looks like a y, equals 1. Negative 4x minus 5y equals 17. Okay, so we can do this either way, but I think it's going to be easiest if we do it with the x's here. So I'm going to multiply this upper one by -2. Whole thing by -2. So that's going to give us negative. Just kidding, multiply by +2. Yeah, it's going to give us 4x minus 14y equals 2. I'm bad with math sometimes. Yeah. And then we still have the same thing down here. That didn't change at all. Okay, so these x's kind of eliminate each other. So then we just have negative 14y and negative 5y. Oh, right, because we set it up like that. It's, yeah, top one plus bottom one. Okay. So then we can add these together. So 14 and 5, that equals negative 19y equals, oh, that's convenient, 19. So y equals -1. Okay, and now that we know that, I'm gonna give myself a little more space here. So now that we know y equals -1, we can come back to either of these equations. It does not matter which one. And yeah, I'll do the -4x minus 5 times -1 equals 17. So really that turns into that. Okay, so then we're going to -5 from everything. So -4x equals 12. X equals -3. Okay, -3 and -1. And we can check this. So we can check it by, so -4 times -3, so 12 minus, so 12 plus 5 equals 17. Yeah, so that checks out. Hooray! It is really awkward when I get one wrong. So yeah, I don't like that. Okay. Oh wow. For nuke/mechanical engineering, we had to do up to Calc 3. I didn't know calculus went up to 3. I knew there was Calc 2. Wow. Didn't even know about Calc 3. Although, okay, nuclear engineering, like, come on, you gotta know all the math in the world. It's nuclear, man. Yeah, nuclear, not nuclear. I'm not George Bush. I think it's funny. Okay. Let's get this equation written down here. Plus 2y equals negative 15. Why did I put that line? Joe man, you're dumb. Alright, forget about the line for a minute. Alright, plus 9y equals negative 21. Okay. I wouldn't say there's an easy way of doing this here. We're just gonna have to make both of them different. So this is not a fraction. I accidentally put a line. All right, so we're gonna multiply u by 2 and u by 3. Negative 6x plus 4y equals negative 30. And then 6x plus, let's see, your times 3, so 27y. What's 21 times 3? 63. Negative 63. Okay, so then these x's cancel out, and then we get 31y equals, because we add these together, it's at 93. Y equals 3. Aha, no, I almost made a mistake there. Y equals negative 3. Okay. So y equals negative 3, we have that. So then we can plug it into either of the equations simply enough. You know, I'll go with the top one here. So negative 3x plus 2 times negative 3, negative 15. There's a lot of negativity going on up here. Negative 3x minus 6, that's negative 15. Negative 3x, so we're going to plus 6 there. It's going to make it negative 9. X equals 3. Cool. Oh yeah, and then we can plug this back into verify. So 2 times 3, that is 6. Negative 3, it's negative 27. So 6 plus negative 27, that's negative 21. Boom. Okay, we verified. Now let's plug in the answers here. So x equals 3 and y is negative 3. Awesome. Nice, we got it. Okay, the function g is defined as follows. So g of x equals x squared plus 8. Okay, simple enough. Squareds give us parabolas. If the graph of g is translated vertically downward by 9 units, it becomes the graph of function h. Okay, so h is that minus 9? Is that what you're saying? For every x, the point x, h of x, on the graph of h is 9 units below the point x, g of x, on the graph of g. That is, the value, h of x, is 9 units less than the value g of x. Yeah, so it's that minus 9. So h of x equals g of x minus 9, which really means this x squared plus 8 minus 9. And so, yeah, just minus 9 from that 8, negative 1. So, in other words, this one, go down here. Simple enough, I think. I'm probably going to be proven wrong. Okay, so here we have h. So we're going to translate it vertically up by 8 units. So it becomes a graph of function f. So f of x. So just upward by 8 units. Simple enough. X squared. So up by 8 units, so negative 6 plus 8. That is, oh, almost made an oopsie. Can't forget my signs. Yeah, so upward by 8. That should be it. And it is. H of x equals 69. Nice. Okay. The function g is that. Translate it vertically. Okay. I hate how they worded this. if the graph of G is translated vertically downward by 6 units, why can't you say just translated downward? Like, okay, I get it, but when I think vertical, I don't know, I just think up. Like, translate it vertically. Oh, it means make it go up. All right, so it's going down. So 5x squared. It's a little awkward to get my hands around my water bottle and microphone and everything. All right, so -4, going downward by 6 units, so -10. Cool. All right, and this one has extra problems to solve. We gotta do at least one more. So let's see, 2x squared, downward by 9. Okay. 2x squared minus 2, because 7 minus 9. Awesome. All right, what do we have next? Oh, cylinders. Okay, completely different area now. We're jumping into geometry. Volume of a cylinder. Okay, this is where pi r squared comes in, right? So, diameter of a cylinder construction pipe is 4 feet. If the pipe is 22 feet long, what is its volume? So I'm pretty sure we just gotta like do half of 4 to get the radius, and then pi r squared. So what's that gonna be? I'm not even looking down yet. I'm just figuring out right here. So let's see, 2 squared. Well, it turns out it's 4 again. Times pi. So that's like 12 something. Times 22 feet long. Okay, let's see if I'm right. So radius r, height h. So the volume equals pi r squared times h. Although I'd say that's more length, but whatever. Okay. So divide by 2, 2 feet. And then we plug that in, becomes 4 again. So yeah, 12 something. Yeah, remember your PEMDAS. You know, this becomes 4 before these go together. Yeah, 12 something times 22 gives you that. All right. Pi r squared. That's an important one to remember. Area of a circle. Okay, the diameter of a cylinder. Okay, it's the same problem. Ah, but you gotta make me square 1.5. Man, you lame. Okay, let's get writing here. So let's try making their equation. So the volume, so pi r squared. So pi is a weird symbol. I think I got it there. So pi. All right. So our radius here is going to be half the diameter. So 1.5 squared. Multiply those. Pi r squared times the length, or I guess it used height, whatever, times 12. All right, so yeah, we just gotta calculator this one up because I only know pi to a few digits. What is it, 3.14159.8? All right, what's pi? 3.14159.2. I was wrong. I know pi to 5 digits. Okay, let's do this. So 1.5 times 1.5, was it 4 something? No, it's 2.25. All right, times 12, 27. I should put this down so you can see it. And then times pi, 84.8, blah, blah, blah. All right, and round your answer to the nearest whole number. Okay. This is going to be square feet. No, wait, no. This is volume, not just surface area, so it'll be cubed. Yeah, so 84.8, that'll just round up to 85. 85 cubic feet. I hope I got this right. Hooray! I'm going to turn the music up just a little bit. Okay. So, same thing here. We just gotta set up the equation. So our volume. Sorry, whenever the pen's hanging, it always gets just a little extra ink on it. So volume is going to equal pi times, what's my radius? 9 feet. Thanks for telling me that. Let's see, r squared. And 45 feet. It's gonna be a much bigger number. Okay, so we're gonna have 81 times 45 times pi, 11,000 something. .105. I know I don't have to do it that precise, but yeah, what can I say? Let's see, round to the nearest whole number. 11451. That's gonna be cubic feet, because 3-dimensional. Uh-oh. Alright, the value is incorrect. So, we were wrong somewhere. So radius is 9 feet, height is 45 feet. What's the volume of the silo? Let's see here. So evidently I went wrong somewhere. Pi r squared times the height, right? This is the most entertaining stream I've seen today. Well, Riptide, I'm curious how many streams you've seen today, because this is math. Math isn't entertaining. Math isn't fun. Okay, so I evidently must have gone wrong somewhere. So radius is 9 feet, right? That's our r. We square the r, pi r squared, times 45. So maybe I just put it in the calculator wrong. Well, here, let's go pi times 81 times 45. 11,451. That's... But that it... What? And it's cubic feet. Round to the nearest whole number. I mean, you can see on the calculator here, it's 11,451.1. So it's going to round down. Huh. So, where did I go wrong? All right, explain this one. Yeah, the answer I entered. Okay. So where did I go wrong here? So, pi r squared. .445. Oh my goodness. I used too much pi, I think. So 3.14 times 81 times 45. 11,445 point. Oh my goodness. It's literally a rounding error thing. Because I used too much pi, it gave me a bigger number. That's literally what it is. Using 3.14 for pi. If I use 3.14159 blah blah blah, it gives me the wrong answer. This is stupid. This is why I hate math. I had the right answer. I had the more accurate answer. Okay? You add some decimals, and you find a few more cubic feet in there, man. Riptide. Assume Master Chief is a cylinder. He's more like a brick, and he does happen to fly pretty good. If he is 3 meters tall, my goodness, that's very tall, and 0.5 meters wide, and weighs 400 pounds, how much does he weigh per cubic meter? Huh. You know, I could actually figure that out. Pi equals 3.14. No! No! Pi equals 3.14159264, and it goes on. Okay, I'm being salty. I need to adjust the camera just a little bit, and yeah. Okay, let's do the next problem here. I'll make sure I use 3.14 for pi. Okay, it does have in the instructions, use value 3.14 for pi. Don't go crazy like I did. Okay, so let's set this up here. So the volume is going to be pi. You know, I'm already going to mess that up. Volume equals 3.14. We're not even going to say pi. Times, all right, what's our radius here? So 13 feet. Make me use 6.5. Half of a prime number. Come on, guys. Times 18. Okay. And then we just got to plug this one into the calculator. So 3.14 times, hold on. First I got to find out my my squared thingy. 42.25 times 18. On camera, this is a great place for the calculator, but for me it's rather inconvenient. Times 3.14. So we get 2,387.97. Okay. Now they want a whole number, and it's pretty close, so 2388. Check. Oh, thanks for catching that. It's always a little thing. Awesome. Okay, next problem. We got just enough room left on the paper here. Alright, so our volume is going to be 3.14 rather than actually using pi. And our radius is 2.5 squared times 27. Okay. And then first we gotta do 2.5 times 2.5, 6.25 times 27 times 3.14, 529.875. But of course, we're going to do some rounding here. Nearest whole number, 530. And it is cubic feet because that's just how volume works. You need to put your math in Johnson's terms. 2 sticks times 1 rock equals 108.33. Solve for rock. You know, the funny thing is I could solve for rock in that equation. Okay, well here, let's check this answer. It's correct. Awesome. Yay, 5 topics learned. All right. Let's see. So yeah, we got 2 sticks times 1 rock equals 108.33. Probably not gonna like the decimals in this, but whatever. So really, I'm gonna simplify this. We got 2s times r equals 108.33. Well, I already don't like this. Here, let's say plus, because he said 2 sticks and a rock, right? It's not like the rock is integrated with the sticks. 2s plus r equals that. R equals 2s, actually negative 2s, plus 108.33. And then we can swap that in. So we get 2s minus 2s. Uh-oh. All right, well that seems to have gone a little bit awry. Yeah, that would break it, huh? Well, maybe I can try the other way. 2s plus r. I literally just did 2 equal signs. So we could do minus r over there. Then we just, when we plug it back in, it does break itself. Haha. It's not an equation. Equal to 117, yeah. Okay, well, you know, funny thing turns out, when you try to just take this one thing and find out what S is equal to, or R, it breaks, because it's not a system of equations, it's just a single equation. Alright, back to the math. Fill in the blank with a number to make the expression a perfect square. Oh, this, Alright, let's see. Off the top of my head, I don't even know. To find what number to add to u squared plus 8u to get a perfect square, we do the following. Find half of the coefficient of u. So 1/2 times 8 equals 4. 4 squared equals 16. I get it. If we were to factor this down, it would make more sense. So half of u squared. Albino buffalo. So I broke math. Yeah, you did. The stick and the rock are undefined. Right, speed run the next one. 6-4. Boom. 49. Boom. Speed run. They gave me easy ones though. Okay, we're in functions and graphs, so we are jumping around different categories. Okay, let's see. So the sets L and H are these things. Find the union and the intersection. Okay, if I remember right, a union is what they have in common, and intersection is just sort of. No, it's the other way around. Okay, union is when we just combine things. There is nothing in common here. Let's see. So union is just one or the other. You don't do repeats. If we had AA, you wouldn't do A, comma A. So, Joe, did you ever slap two hard socks together? Hard socks. I mean, I have done the thing where like you hit the socks together like that, and then they sort of like wrap around each other. I've done that with socks. They weren't very hard though. Bro, are you really doing math homework? Yes, I am. Yes, I am. Yeah, it is what it is. It's math. All right, I'm getting distracted. Union is all the things. Intersection is only if it's one and like if it's in both. So here we go. So G is that, B is that, C is going to be in the union. I can tell you that much. So yeah. So C. Oh, hold on. I got to do braces. All right, C, and then intersection. Gotta do our braces here. So intersection is just sort of gonna be everything else. So B, D, J, K. B, D, J, K. I think I got that right. So intersection. Do I have this backwards? I think I have this backwards actually. Hold on. I think they pulled a switcheroo on me. Okay, intersection is where it's both. So that would be. Are these even in order? Intersection. I need to memorize the symbols. That's the problem. Okay, so union appears in the first set or the second set. Intersection. Okay, U, union. Upside down U. We'll say U, union, N, intersection. U is union, N is intersection. Okay, so the intersection of them. I had this right at first. The intersection, which is both of them, is C. And then the union, one or the other. It's B, D, J. Oh, got that wrong. J, K. Okay. My keyboard's. I have to reach around my water bottle, which is holding up my webcam. BDJK. All right, I think we got this. I did not get this. All right, so union was correct. Huh. Did I miss something with the intersection? Yeah. Yeah, so I'm in college. This is pre-calculus. Well, it's preparation for pre-calculus. So, Bus Rubber, welcome to the stream. I asked you in a Minecraft live stream with Andrew. Oh, about the hard socks thing. Okay. This is what I subbed for. Yeah. Okay, so evidently I got something wrong here. So it's saying that the union here is what's wrong. Union U is things that appear. Did I forget C? I think it's that I forgot C. Yeah, because it's not like being in the intersection makes it uneligible for the union. That's what it was. Okay. Yeah, so this is one and the other. This is one or the other. And it doesn't kick one out, so. Okay. Let's keep moving here. I definitely need the practice, obviously. So, J and D. I'm just going to throw braces in here because it's going to require them. I don't want to forget. So no, this is union, this is intersection, because that kind of looks like an N. Intersection. All right, Bus Rubber, have a good sleep. Pre-calculus is like legendary difficult for me. Well, it lasts a run if it involved math in general. Yeah. Vector calculus. I don't know, that sounds like there would be something visual with it. That might help. I'm distracted. Okay, so what is in both of these? 8. 8 is the only intersection. It's the only thing that's in both of them. And then we have all the stuff that is in one or the other, which is all of those numbers. Hooray! All right, we got one more, assuming we get it right. Now I'm just going to throw the braces in here because if I don't do that, it's going to yell at me. I don't want to get yelled at. Okay, so they're swapping it up here. Intersection's down here this time. We got 0, and that's it. And then, all right, and then the union, one or the other. We got -2, -1, 0, 2, 4, 6, 7, 8. One or the other, one and the other. Check. Hooray! Awesome, we've got 7 topics learned. Imagine finding a 3D graph of integrals. You're speaking beyond me. I'm just, yeah. All right, simplify. We got fractions over fractions. This baby can hold so many fractions. This is a complex fraction. I like it. I like to call it a fraction squared, except that's not at all what it is. Okay, so you have your fraction over your fraction, and okay, so you add this into the numerator. Interesting. Okay, so 1 minus that. So you take 5 out of the 7 because basically it's like 5/5. 5/5 minus 7/5, you know? You get -2/5. Okay. And so then 1 over the other. So then you write it out horizontally. And okay, so if you just sort of swap one of them, then you can multiply them together. And in that case, you just go straight across. Okay, so I am going to write this down. So 2 plus 3/4 over 1 minus 5/7. So really 11 over 4 over -2 over 5. And then they did a little switcheroo here. So 11 over 4 times negative 5 over 2. That's not a great 11, is it? Oh well. Negative 55 over 8. All right, so a little switcheroo. That's the trick here. And then we can also write this as that. So, okay, here we go. I'm actually gonna move my water bottle up top here. All right, let's do this thing. So we have 3/4 minus 5/2 all over 1/5 minus 1/2. Okay, so there's no simplifying to do in the first place here. Okay, so it didn't really say before. I think there's two ways we could go about this. We could either do all of this times all of that, but I think what we should do instead is get a single fraction up here, a single one down here. So, 3/4 minus 10/4 over, let's see, 2/10 minus 5/10. Okay, so we made the denominators the same, so now we can math this out a little bit. So 3 minus 10, it's going to be negative 7/4 over 2 minus 5, it's negative 3/10. Okay. So then we can, let's see, so it's that over that. So then we can do a little switcheroo here. So negative 7/4 times negative 10 over 3. Little switcheroo. I think that's right. That's going to give us a positive 70 over 12. Let's see, I think I could actually pull some stuff out of there. 64, right? No, that's wrong. 60. 12 times 5 is 60, yeah. 5 and 10/12, which that goes down to 5/6. But I'm just gonna do 70 over 12. I hope this is right. Let me do double check a little bit here. I was confident up to here. Switcheroo. Negative times negative gives you positive. Yeah. Oh, sorry. I realized I kind of cut off the end there a little bit. Okay. No, it wants it in simplest form. Let's see. So 70 over 12. We can pull 12 out of there 5 times. 5 and 5/6. I don't want 55. Okay, I think I see what I gotta do here. I gotta use their special buttons. Okay, 5 and 5/6. Hooray! Okay. Moving onward here. 2 over 3 over 10 over 7 minus 6. Okay, so that 2 over 3 is just going to stay there for a minute, but we've got to address what's down here. So 10 over 7, really this is 6 over 1. So I just need to make the denominators the same. So really it's going to be 10 over 7 minus 42 over 7. And then, yeah, the 2/3 is still up there. And it's going to stay up there for even longer. So 10 minus 42 gives us negative 32 over 7. And then, let's see. We do our little switcheroo. So 2 over 3 times, I know I keep, like I did a dot here, I'm doing x times here. I don't even know, man. All right, times negative 7 over 32. I do not like this. We're gonna have a huge denominator. All right, negative 14 over, what's that, 96? Is that 96? Nice. Okay. And we need to simplify a little bit. So we can divide that by 2. Equals negative 7 over, what's that? 48. All right, 48 does not divide by 7, so negative 7 over 48. Awesome. Shadow Elite, how old are you? I am 26. Going through college a little slow, but I am going. I'm paying for myself. No loans. Okay, jumping into real numbers. Identify numbers as rational or irrational. There was a graph. No, not. There was a Venn diagram. Is that the right thing? There was a thing that I saw that really helped with this. Yeah, so rational or irrational. Let's see what it defines that as. Okay, that's hard. Let me look something up here. Okay. Okay, this makes a lot more sense here. Okay, I'm just gonna put that there. So, basically, yeah, this makes a lot more sense to me. Yeah, so natural numbers is just everything above 0 and its whole numbers. And then whole numbers, which literally just adds 0 to it. That's the only difference. Integers, rational numbers. So these do fractions and stuff. So irrational numbers. Whoops. There we go. Irrational numbers. I think that's when you get like pi and square root of 2 and yeah. So square root of 2. That's just like an endless sort of number. And yeah, these other square roots are crazy. Square root of 9 is fine because that just breaks down to 3. Cube root of 9 would probably be irrational. Probably. Okay. So I would say irrational, rational, irrational because that's a prime number. Ooh. Well, the negative is outside, so I think that's rational. And then I think this line means that it goes on and on, which would make it irrational. Let's see what it says. The ordinary fractions are rational. So integers are rational. Terminating decimals are rational. So in other words, if it ends, it's rational. If it doesn't end, 0.33333333 going on forever, it is also rational. Okay, so then I take that back. This is rational then. It's rational because it would also be 1/3, which is also rational. Okay. Square root of 2 is irrational because 2 is not a perfect square. 4 is fine because it just breaks down to 2. 2 square root of 3 and 3 pi are irrational. This one, because it has pi. This one, because it has square root of 3. So, how did it mark? Irrational. Rational. Irrational. Prime. Rational. Yeah, the 7 would just pop out, which it says up here. And rational, because it goes on forever, which is fine. I think. Wait, so why is pi irrational? It goes on forever too. Maybe it's because it changes, whereas this one could be a fraction. Okay, I think I got it. It's funny how basic math, like grade school math, goes out the window when algebra is involved. Unless I have a scientific calculator, then my day is saved. Danny the person, welcome to the stream. We are doing some math here. Classify each number below as a rational or irrational number. So this one has pi, so it's irrational, because pi is just too crazy. I would say Aunt Sally is irrational after what we learned about her in the last week's stream. That's right, Aunt Sally. Things got crazy last week, man. Alright, this one, it's just a fraction. It's fine. This one, it goes on forever, but that's fine. It could just be a negative fraction. The square root of 1 is a problem. Is it? Ooh, that's a good question. Oh yeah, pi is irrational because you can't represent it as a fraction. Yeah, that makes a lot more sense. Okay, so square root of 1 would be just 1, because 1 times 1 equals 1. You can pull a million ones out of 1, you know? 1 times 1 times 1 times 1 equals 1. And this negative is outside, so I think that's rational. They're trying to trick me right there. 14, oh, that's 2 and 7 in there, which, yeah, you can't really represent that. So I think that is how we got this. So let's check. Hooray! Yeah. Our real numbers category is almost filled up. We almost know all of our real numbers. Classify each number below as a rational number or irrational. Okay, so this one goes on forever, which is fine, because that implies we could represent it as a fraction. This has a square root of 2, which is not fine. This has pi, which is not fine. You could pull 2 out of that, so that's fine. And this is just a fraction, which is fine. Awesome. Dude, I'm on a learning streak. All right. Guys, we completed a slice of the pie! I learned all 30 topics in the real numbers slice. Oh no! Does that mean there's 30 topics in every slice? Hold on. Let's get full screen with this thing here. Let's zoom in on this pie here. Let's get in on this pie. Okay, so we completed everything with real numbers, which is 30 topics. Okay, it's not 30 topics for everything. Equations and inequalities has 32, which I've learned 25. I've learned 26 of. 6 remaining. Okay. Yo, we can make a game plan here. Okay, hold on. So we got 6 remaining. 13 remaining. That's 19. That's 13, 20, 32. 52. 61, 71, 76, 86, 92. We got 92 topics left. 92 left. That's a lot. Wow. Phoenix Merlin. Why is this in my suggestions? Maybe you need to learn some math, Phoenix. I don't know. Yeah, I'm just doing math homework. Like, I don't expect it to be entertaining. I try, but at the same time, you know, it is what it is. So, okay. Well, I think let's get back into it. I'm feeling good. So, yeah, the math pie, the most deadliest pie of all. Yeah. All right. So I'm gonna continue here. Write an equation of the line below. Depends on the equation you want. So y equals mx plus b. Okay, so we just gotta figure out our start point of the y-intersect and our slope. So it's gonna be plus 0, so we won't even write that part of it. So our slope appears to be a rise of -1, a run. Did I just say negative run? A rise of -1, a run of 2. So -2. Yeah, y equals -2x. Okay, so what does it say down here now? I like to try and figure it out and then see the explanation to see if I'm right. Because if I am right, it's already in my brain, which is awesome. So, Yeah. Any non-vertical line can be described by an equation of the following form. You know, vertical lines can be explained too, but they're not. They're no solution, so or they're undefined, something like that. All right, this is the slope-intercept form. So b equals 0. Got it. Okay, this is important. I just thought it was 2, but if we follow it here, we'll see that it doesn't so kindly intersect. This is why these points were important. So it's going to be 5 over 3. 3 over 5. Yeah. Rise over run. Rise is negative 3 over 5. I'm glad it showed me this. Let's see if I can remember it. So, write an equation of the line below. So our intercept is going to be 4. So y equals, I don't know what x is yet. I'm just going to put x as a placeholder. This is not my final answer. So it's plus 4. So we know it goes down 4 and over 6. So negative 4 over 6, which is negative 2 over 3. So rise of negative 2, run of 3, negative 2, run of 3. And that should be it. Awesome. Okay. Write an equation of the line below. So our intersect is going to be negative 1. Alright, now figure out x. I just find it easier to do the intersects first. It's just, you know, easy. So, we go down 8 and over 2. Negative 8 over 2, but that can simplify down to just negative 4, which is awesome. I mean, negative 4 over 1, but you don't write the over 1. So, negative 4x minus 1. Awesome. Insane gamer, gotta go to bed. Understandable. I'll probably do this for another half hour or so. And I'm actually getting kind of thirsty, so here, you get to look at me upside down while I take a drink. Yeah. Joe Man drinks water upside down while slightly out of focus. Okay. You know, I'm just going to stay here for a minute, actually. Yeah. We're just going to stay like this while I do my problems until I actually need my paper. Why not? Be upside down for the stream. All right, so graph the thing. Y is less than 4. So there's 4. Y is less than that. Got it. Okay. So, I think I got to make a line. So y is greater than negative 7. So come down here to negative 7. And then I think we do region. Okay, yeah. So there's negative 7. Y is greater than it. Okay, that is incorrect. I must have used their tools somehow incorrectly. Let me start over. Alright, well, I clearly don't know what I'm doing with this thing. No, we don't want the whole thing. Negative 7. Oh, that's what I didn't do. It's greater than, not greater than or equal to. I gotta turn it into a dashed line. Alright, then we shade that top area. That should do it, I think. Okay, there we go. Yeah, sometimes you're just figuring out the tools, you know. Lines and systems, that's the category now. Alright, x is less than negative 1. So, come over here, negative 1. It's less than. So we make that dash, region, boom, check. Alright, we got one more here. Y is greater than or equal to 6. Come up here to 6. Draw our line. And, well, actually, we're not going to dash it. I could, but no. Because it is greater than or equal to 6. And then we'll shade everything above 6. Awesome. CRISPR Core 2, we love infinite planes. Yep. Wouldn't want to have a limit to our planes now, would we? Okay, I'm probably going to need my paper for this one. Solve for u, where u is a real number. Haha, let's just assume all this stuff is real. So, the way I see it is we're going to have to multiply them a certain way to pull them out. Oh, we just square, yeah, multiply them by themselves. So, yeah, we just square them. I foresee that there will be a math problem where only one side is in the square root. So you still got to square both sides, you know, keep things equal. All right, so then we have our u's, and then u equals the thing. So, oh, because we solve by squaring, we must check that u equals 11 satisfies the original equation. So then we got to stick 11 in there and see if it's true to find out if it's a solution, actually. So you do have to go back and check this, which I do, but... Okay, well, I'm going to move my camera again. Actually, get new. No, I got room on this paper. Okay. Yeah, my camera is literally just sort of hanging off my water bottle. Come here. The cord is fighting me a little bit. Okay. Let's do some math. So square root of 9w minus 15 equals square root of 7w minus 1. So yeah, we're just sort of going to square everything. Yeah. Perfect. All right, then we'll start by moving the 15 over. Let's see, what am I even trying to do here? Oh yeah, plus 15. That goes there. Then minus 7w. Alright, so then we know w equals 7. But we have to go check it. And I need to focus my camera. There we go. Yeah. W equals 7. But does it? Well, let's find out. So you can plug the 7 in up here. I'm going to do this off to the side. So 9, 7 minus 15. We're looking for two things. A, can we even make this come out to something? I guess technically we don't have to do that. But more importantly, do the sides equal. So if w is 7, let's see what we can pull out here. So 9 times 7. Staying in the square root here, we got 63 minus 15. We got 49 minus 1. 63 minus 15. Let's see, minus 5 is 58. 48. Square root 48 equals, hey, guess what? Square root of 48. So yeah, w equals 7. And we have proven it is valid. I mean, I don't really need to solve the square roots beyond that. I could. I don't need to. I just got them equal. Hooray! And, all equal to 0. I have a feeling I'm not going to like this one. Okay, let's get into this here. 7y plus 8 minus square root of 2y plus 3 equals 0. Yeah, I don't think I'm going to like this one. Because, well, I can square the whole thing. The problem is 0 squared is still 0, so Okay, so there's that. Got 5y plus 11. 5y equals negative 11. Y equals negative 11 over 5. Add the second half of the equation to both sides. Oh, plus 2y. You know, that makes a lot of sense. Because, yeah, this y right here is garbage. So I like your suggestion. Plus square root of 2y plus 3. Yeah, that was going to be my second option. For real. Alright, so we still go. Let me just skip the whole squaring everything. 7y plus 8 equals 2y plus 3. Yeah. 5y. Let's see, minus 8 over there. Negative 5. Y equals negative 1. Okay, so if I plug this in up there, these should come out to be the same because 1 minus the other is going to equal 0. So negative 1. I'm just going to do this in my mind. I'm going to imagine it. So negative 7 plus 8, that's 1. And then negative 1, that's 1. 1 minus 1 does equal 0. Y equals negative 1. Sorry, I realized it was starting to cut off a little bit there. Yes, so y equals negative 1. Awesome. Alright, geometry. A rectangle is placed around a semicircle, as shown below. The width of the rectangle is 8 yards. Okay, I can already tell. It wants me to find the area of the shaded, so we need to start with the area of this, get rid of the area of that. Probably. Okay. So, what's it going to have us do here? Well, what we know is this is 8 yards. And this is a perfect circle, and this is half of it. So we know this is going to be twice the length, which is 16 yards. So we'll have 16, we'll have 8. 8 happens to also be the radius. So 16 times 8, that's going to be, what, 80, 48. It's going to be 128 minus the area of the circle. So pi r squared. So 64 times pi, that's a 180-ish, 200. All right, let's walk through here. I'm having a hard time doing all of them in my head. So 128 yards squared for the rectangle, got it. And that's semicircle. The 200 something that I said earlier, half that because it's only half a circle. Yeah, 128 is about 100 yards squared in the semicircle. And so then that shaded area is just about 27 yards squared. Okay. So let's figure this next part out here. So we have a circle and a square. So first, okay, that is the worst square in existence. This is literally graph paper. I should be able to make square. Okay, so the square is going to equal, let's see, 8 times 8, it's going to be 64 square feet. So 64 square feet. And then circle, so pi r squared, it only wants me to use 3.14. So 3.14 times radius is 4. Alright, so it's 16. I already know. Gotta do a little calculator work here. 0.14 times 16, 50.24. So 64 minus 50.24. Awesome. So it's really just that minus that. 13.76. Do not round your answer. Okay, so in other words, round it to the nearest hundredth. Yeah. I guess if you use 13.14, that'll kind of handles rounding for you, right? Okay, so rectangle minus a circle gives us that shaded area. Should work, and it does. Awesome. Okay, so then, oh no, triangles. Okay, so I'm trying to remember how you. Okay, I think I got this. So 7 meters tall, and it's a right triangle. Okay, so so I gotta work through this one. So 7 meters tall. So we can make a rectangle out of that. I'm gonna represent it as a square. So that's going to be 7 by 14, which is 98. Just trust me for a minute here. 98. And then those triangles. Here, let me draw just a little bit here. Okay. So, terrible at drawing. Alright, so if we have right angles there, then we know that half of that rectangle is going to be the triangle. So the triangle, kind of fill it in a little bit. The triangle is going to be half of 98, 49. Okay, so 49 is the triangle area. And now we got to figure out the circle's area so that we can minus the triangle's area from half of that circle. Okay, so the circle, 3.14, the pi r squared. What's the r going to be here? And 7, so 49. Bring in the calculator here. 3.14 times 49. That equals 153.86. And then want to divide that in half. So 76.93. Yep. 93. And then we want to minus the triangle from it. Minus 49. Man, this has been very convoluted. 27.93. Okay, I really hope I got this. 27.93 millimeters squared. Awesome! Man, that was convoluted. It's very convoluted. I'm on a learning streak. Awesome. Okay, about 15 minutes and then I can end the stream here. I feel like I'm on a good roll. Haven't had too many holdups here. All right, divide that by that. Well, we just swap them, right? And then multiply straight across. Multiplying by its reciprocal. So we take that, we flip the second one, and then we just multiply straight across. And then some things kind of cancel out a little bit. So these a's cancel out, some of the b's cancel out, and you simplify the numbers. So 5 over 2, a's are gone, b cubed. Yeah, okay. Seems simple enough. So let's get our equation set up here. Okay, I'm just gonna do the flip immediately. Multiply by the reciprocal. Y to the 5th. Okay, we multiply straight across. So 4x times 9y give us 36 x y over, and then 8 times 3 is going to give us 24 x to the 4th y to the 6th, because really this is y to the 1, so y1, y5. When you multiply and they have exponents, you just add the exponents together, so y to the 6th. And then I'm having a hard time looking around my microphone here. I know you can't see it, but the struggle is real. So these definitely simplify down. So if I divide those by 12, that'll give us 3 over 2. Then the x's and the y's from the top are gone. X to the 3rd, y to the 5th. Okay. 2x to the 3rd, y to the 5th. I think that's it. Awesome. Feeling pretty good. Hope that continues. Okay, so 2b, or not 2b, y. 2b y over 5y to the 4th. I'm going to do the flip immediately. 15y over 4b. Multiply straight across. 30b y squared. 30 by. And then that is over 20. 20b y to the 4th. So, kind of get a similar answer here. Got 3 over 2 again, 30 over 20. And then the b's cancel out completely. We're just left with some y squared at the bottom. Cool. 2y squared. Awesome. We're doing so good tonight. Rational expressions. Okay. Add the thingies. Well, they have the same denominator, so we can just add across, right? The carrot taker. Here's some motivational bread for your journey. Thank you. You know, I am a little bit hungry. I could do with some bread. I have definitely been guilty of literally just going and grabbing a slice of white bread and eating it for a snack. Just piece of bread. Nothing on it. Just bread. Yeah. Okay. So first we do our PEMDAS and do that stuff. And then because the denominator is the same, then they can all be one big half B family. Denominator doesn't go away. It just sort of gets under everything. And then you just add things together as you can. And boom, there's your answer. So, okay. Let's get a new page here. Okay. Now Now this is math music. That is a terrible b. Over 4b. I'm not sure that's really a better b either. Whatever. 7b minus 3y over 4. Apparently I just wanted to write the b first. Okay. So it's gonna all be over 4b because it's, yeah. I don't need to explain it. All right, 9b minus 6y minus 7b minus 3y. Running off the edge a little bit. Okay, we can only add or subtract them if they're the same variable within the first place. So 9b minus 7b leaves us with 2b, or not 2b. That's the question. All right, negative 6y minus 3y minus 9y all over 4b. Okay. All right, I'm just gonna start the fraction immediately. This is gonna be a little long here. Rin 1 plus 3yt. Okay. All right, let me double check my stuff here, make sure I'm not going crazy. So over 4b, that stays there. I think I got it. Check. No. Okay. It might be that all of this gets negativified. So let's try this again. So let's see. So I think this might be the alternative I'm looking for. We still have 2b. It's just the y's that I think are different. I think that's it. Riptide, welcome back. I got an answer wrong. I think this one is it. Yep, there we go. Okay. Gotta remember, when there's negative here, it negativifies that. So minus 7, which I did, I just didn't apply it to the 3y. So negative negative equals positive. You know, 2 wrongs make a right. 2 negatives make a positive. Okay. Here we go. That's a big old negative sign. Minus a minus 9b over 5a 4a plus 3b. That's over 5a. Okay, so they're all over 5a. Gotta remember this negative is gonna apply to all this over here, and this one's negative too. So I hope I get this right. So we're gonna have, so this negative is gonna apply to the thing. So negative a plus 9b minus 4a minus 3b all over 5a. I think that's it. Riptide, give me the spoilers, give me the answer already. No, I gotta figure it out for myself, man. All right, negative a. Yeah, so negative 5a plus 6b over, wait, over 5a. That is a different answer than Riptide provided. So it's kind of making me doubt. All right, let's double check here. So it's negative. Applied it to the thingies. It's negative. Applied it to the thingies. I don't know. It's a different answer than Riptide was given. I'm trying to think how do you get negative 3a minus 12b? Probably because you did a negative a. A minus 4a is probably what happened there. But the negative at the beginning applies to all this. I feel confident in my answer. That is... We put this whole thing in a fraction. Nice. Okay. Alright, we're gonna find out. Ah, I am correct. Sorry, Riptide. Okay, if we can get one more correct, then we can move on to the next thing. Okay. So what do we got next here? Oh, pretty similar. It's negative a minus 6x over 2a plus 6a minus 8x over 2a. Okay, so as we learned last time, negative a plus 6x plus 6a minus 8x. All that over 2a. And then we math that down a little bit here. Five a. Let's see, 6x minus 8x, that's negative 2x over 2a. Let's see, we'll start with a fraction here. 5a minus 2x over 2a. Double check my work here. Looks good, looks good. Yeah, I think I got it. Awesome. Yo, 15 topics learned. Normally we go for 20, but we are getting into harder topics. So I think I'm gonna call it there actually. I have been streaming for a couple hours. So yeah. Let me get my microphone or my webcam back in place. I think it's time to end the stream. We did great tonight. There we go. Not nearly as bad as last time. Well, hold on. So, for those that I didn't hear it earlier in the stream, my plan is let me pull up my calendar here while I stay upside down. So we got my calendar. Today is the 10th of August. School starts on 29th, but I don't want to be doing my test right before then, right? So next week, 17th, I'm going to do another math stream. And then after that, maybe on that weekend or something, I'm going to do the actual test to see. The whole goal here is that I am wanting to get into calculus, right? Calculus is the math class to beat. But I need to test high enough to even qualify to take calculus, right? Can't just have anyone take calculus. You gotta pass pre-calculus before you can take calculus. So I know testing that high is really hard. So my goal is to test high enough to get into pre-calculus, take that, take calculus, take physics. That's just 3 classes. Pre-calculus, calculus, physics. I did take the test 4. My score was not good enough for pre-calculus. So the goal is to test high enough to get in pre-calculus. That's why I'm doing this, preparing to take the test. Then I can get into that. Anyway, so yeah, that said, math stream next week, same time, 7 p.m. Mountain Time, and then I'll take the actual test after that, off stream. I'm not streaming, taking an official test. And then, yeah. Then if I get that, maybe no stream here, a little cool off before school. But yeah, we'll see. So, Thrive Fan Central. sorry to say, I am just about to end the stream here. Yeah, it is that time. I've been streaming math for 2 hours. I have a notebook to prove it, and a stream to prove it too. So yeah, I think it is time to end. Last week I did 4 hours of math. It was brutal. Let me tell you. I do not recommend it. So I gotta find the right song, the certain song I end my streams with. Okay. Yep, time to end the stream. So I will also have my regular Friday stream. That is coming. Saturday, actually, I have a drift event. So haven't been drifting in a while. I do have a few videos on that, though. So if you want to go see me drifting, I have a few videos for it. You could probably search that up. So Jude Barrett, you just got here. I'm sorry, we're closing out the stream here. Yeah, 2 days from now, Friday, 7 p.m., I'll have my regular weekly stream, play games, do fun stuff, not math, and then we'll hopefully see all of you there. But until then, I'm JoeMan543. Thanks for joining for this math stream. Crazy how anyone would watch math, but in any case, y'all were here, y'all watched, and I thank you for that. Hope to see you next time.